All right, Track Safety Standards Compliance Manual, Chapter 5, Classes 1 through 5, April 1st, 2007. Subpart C, Track Geometry, 21351 Scope. The subpart prescribes the requirements of the gauge, alignment, surface of the track, the elevation, outer rails, and speed limitations of the curved track. C, Guidance C, Figure 3 for the illustration basic track geometry concept. Profile the surface on uniform in the vertical plane of each of the railroad measurement is a midpoint of 62-foot chord. Profile with the gauge and alignment in 31 and 60-foot two-chord alignment of the uniform of the horizontal plane. Each of the railroad measurement midpoint of 61 and 31-foot chord. 21353 gauge. The gauge is measured between the heads of the rail and the right angle of the rail with the plane and the 5/8 of an inch below the top of the rail head. This shows the tie plate cut and the outward cant and inward cant, lateral shift. Wide gauge is 58, narrow gauge is 55 and 7/8, and standard gauge is 56.5 with a 5/8 of an inch of the tread. 53B gauge must be within the limits prescribed in the following table. The class of track is depth of track of notice of an application, but more than 4 foot 10 and a quarter inches, which is 58 and a quarter. Class track 1, the gauge must be at least 4 foot 8, not more than 50 and 58. Classes 2 through track from 4 foot 8 inches, which is 56 or 4 foot and 9 3/4. Class 4 track 4/8 of inches, not more than 4 and 9.5 inches. The guidance of rules establish the minimum and maximum limit of the gauge of all the tracks differential for the authorized speed, including the maximum gauge dimension of the 4 foot 10 and quarter of an inch of the track inspected for the status under Title 13.4. Inspectors will measure the service sufficient intervals assured of the track at the beginning of the maintained with the prescribed limits. Particular attention should be given to the track gauge and turnout locations while high lateral train forces are expected evident. The areas include the curvature cross rails with the toe and heel frog of the curved track of the behind the frog of several feet ahead of the switch point. Where the line of surface irregularities observed with the inspection of the gauge shall be measured. Remember to look for evidence of lateral rail movement as required in Statute 213.13. And accurate standard track gauge device, a rule graduated with an inches acceptable measuring device. The gauge within the specified with the track safety limits is in non-compliance. Alignment. The alignment may not deviate the uniform more than the amount prescribed in the following. Class 1 track, the tangent track of 5 inches and not applicable. The curved deviation of 31-foot chord and 5 inches of a 62-foot chord. Class 2 track 3 inches and not applicable. 3 inches of a 62-foot deviated chord may not be more than 3 inches. Class of track tangency of 62 foot is at 1 3/4 of an inch. Deviation of mid-orientated 31-foot chord may not be more than 1 1/4 inch. Deviation mid-oriented of 62-foot chord may not be more than 1 3/4 of an inch. Class number 4 track deviation of mid-offset 62-foot line may not be more than 1.5 an inch, and deviation of the mid-orientated with the 31-foot may not be more than 1 inch, or on the deviation mid-orient with 62-foot chord may not be more than 1.5 inch. For the 5 class 5 track with tangent at 3/4 of an inch, 31 foot at 1.5, and 62 foot at 5/8 of an inch. Guidance. The rules establish maximum alignment deviation allowed with the tangent curve in the class tracks 1 through 5. The speed alignment is the variation in the curvature of each of the rail of the track. The tangent is intended with the curvature of 0. Thus, alignment is measured as the variation of the deviation from 0. In curving, the alignment is measured for the variation deviation from the uniform alignment over the specified distance. The inspector should note that the procedures to determine the uniformity with the class of 9 are similar with the procedures described below. However, the difference in spacing the stations of the application of the chord measurement, the point of the greatest alignment, the deviation usually can be detected visually and may be located moving the chord with the track of the instruments until the point of the maximum deviation is found with the control curve. The mid-orientated alternative called the mid-chord offset require the station to be marked with regular intervals on the high rail both direction for the point of the question and tangent. The mid-chord offset is measured directly at within 62 foot of the chord, graduated with the ruler and curves In the curves, the 62-foot chord in these class 1 through 5, the 31-foot chord is also used for class 3 through 5. The term mid-chord offset is used interchangeably with mid-ordination and mid-offset, representing the distance between the rail and the chord at the midpoint of the mid-chord. For example, the Class 3 and through Class 5 tracks alignment with the defect may be in compliance with the effect. Either the maximum limit of 31-foot chord or the 62-foot chord, both the 31-foot chord particularly necessary to determine short alignment deviations. The inspector must be aware a 62-foot chord may be blind to short alignment deviation conditions, whereas the 31-foot chord can detect those non-compliant conditions. See Figure 5. Class 3 through 5, both the 31-foot and 62-foot chord must be used corresponding. The measurements be calculated, determining compliance with the required alignment thresholds. The alignment defects are found to be using a 31-foot, 62-foot chord. Inspector should report them in one of the defect mentor. Note the defects does not comply with the requirements. The second chord, 1/3 of an inch alignment deviation on a curved track. The 62-foot chord, note that a 1/3 inch in alignment deviation of 31-foot chord at the location. The chord line will be sketched and the chord line will be sketched and held taut between 2 points of the rail at 5/8 of an inch below the top of the running surface, measuring between the mid-chord offset between the rail and the string. Graduated ruler using the blocks to compensate the shell curvature. Special track work as necessary. Alright, this shows the 31-foot chord and the 61-foot chord between 31-foot chord between 3 and 7 and 4 and 6, and in the middle of 5 and 31-foot chord and 62. Alright, since the true tangent of the zero of the mid-chord offset, the measurement taken with compared directly to the alignment table of the statute 21355 determines compliance. One curve of the constant curvature, each of the arc of the compound curve mid-ordinance of all the station points at the equal and measured for the chord's equal length. The exclusive spirals and mid-chord offset measured by the chords of the equal length of the merely potentially proportionally each degree of the curvature. The degree of the curvature angle superintended with the center line of the end curve of the 100-foot. The chord, the degree of the curvature can be conveniently measured using a 62-foot chord. Obtaining the degree of the curvature coupled with the average elevation and area. Questions necessary to determine the maximum authorized speed. Please refer to the statute 21357 for the discussion determined with the curvature. Deviation alignment with the curvature requires the determination of mid-chord offset over the specified number of the stations. The average of those values, the difference between the mid-chord offset at the point of contact. Point of concern, the average must exceed the maximum deviation specified in Table 21355. As shown in Table 5, the optional method of determining average alignment includes 17 stations spaced out in 15-foot, 6 inches, curves classes 3 and through 5, if necessary, determining the compliance requirements for maximum deviation of mid-chord offset from the 31-foot chord, in addition with a 62-foot chord. Figure 6 illustrates the method determining alignment deviation using both chords. Alright, your 31-foot and your 62-foot inches with a 1.5 foot high and 3 1/4 inch is 3.5 between this mid-chord offset is 62 foot. When using above, the procedure, the distance between the first and the last mid-chord offset should be 248 feet. However, the measure of the mid-chord offset the first and the last station, the inspector must place the end of the string of the station beyond the first or the last one measured, and the reference of the following of the table summarizes the acceptable proper of the chord station and spacing number of the stations to determine alignment and compliance. Alignment stations. Curvature of one is one class 1 to 2 chord, 62 foot. Total number of stations 9 or 17 stations spacing 31 foot or 15.5. Curve length curvature 2 1/48. Class 3, 3, 5, 31 foot chord and 62 foot chord. 17, 9 or 17, 15.5, 31, 15.5, 248 curvature length, tangent 1 through 5, class 62-foot chord, total number of stations 1, not applicable spacing or not applicable curve length. As previously indicated, the suspected alignment curve location of the curved body calculated measuring equal number of the stations on each side of the area of the question. The majority of the currency of averaging the mid-core or to offset the both sides of the location of the question that developed sufficient data to determine the uniform alignment. However, the location is in question close of the total spiral uniformity must be determined in a different manner if the location located with the portion of the curved body close to the special spiral measure of the station curve of the body only with the shaft and the ray averaging sufficiently so that none of the mid-chord offsets are in the spiral. When measuring the body of the curve, the length and less than the distance spanned by the required number of the sections, reduce the number of the status. Accordingly, when the measuring the compound curve is necessary to measure the mid-chord offsets within the sufficient portion of the entire curve to determine where the curved bodies exist, to treat each of the curved body with a separate curve governed by the above instructions. Over the years, the railroad has traditionally used the 31-foot chord to determine the mid-chord offsets of the high-degree curves. Although the difficulty measure of the rail with the mid-chord offset of the high-degree curves, the spectrum must determine the alignment compliance in accordance with both 62-foot and 31-foot chords described in this section. In spirals, alignment with the gradually change with the tangents, the full degree of the curvature at the curved body thoroughly determine the alignment of the deviation at the given point of the spiral, with necessary to determine the mid-chord offset based on the project value at each point of concern. This method of determining the projected value of each point of the measurement with the mid-chord offsets through the entire spiral question. The importance is determined with the mid-chord offset sufficient distance of the joining of the curved body and the tangent track to currently determine the tangent to the spiral to the curve. Place measured values in the graph and plotted with the spiral deviation point of the concern, the differential between the mid-chord offset and this project value. Using the core values for the alignment of the table to determine the compliance with the spiral. Figure 7 shows the spiral calculation 62-foot chord mid-chord offset units of 1/16 of an inch increment. Similar analysis is required in 31-foot chord through class 3 through 5 and station 5, existing in value 18 inches of 1 1/8 of an inch. Projected value of 12 inches or 12 units or 3/4 of an inch. Therefore, the deviation uniformity is 6 units or 3/8 of an inch measured in average. Alright, 213.57 curvature, elevation, speed limitation, 15.7a. The maximum cross level outside of the rail, the curvature may not be more than 8 inches on the track classes of 1 through and 7, 1 and 2, and 7 inches on classes 3 through 5. Except for as provided in statute 213.63, outside of the rail of the curvature may not be lower than the inside of the rail. Guidance. Paragraph does not apply more than 6 inches to provide elevation recommended with the curve. Further than paragraph limited amount of the cross level of the curvature controlling the unload of the wheels high rail with especially low speed. The cross level limits with not standing the standard emphasis. Establish the maximum cross level at any point of the curve, which may not be more than 8 inches of class 1 and 2, 7 inches in class 3 and 5. The curve at the cross level measured with distracting relative difference in the height and the top of the surface tread and inside of the lower rail of the tread of the outside high rail. Both 213.63 of this section limited the amount of the reverse elevation outside the rail lower than the inside rail. On the table 213.63, the permanent reverse election of elevation of the curve of the Vmax formula using the checked reverse elevation is encountered. The inspection must be substitute negative number for the actual evaluation of the formula as discussed below. The Vmax formula applies to the body of the curve. 57B1, the maximum allowable operating speed for each of the curves is determined by the following formula. Vmax is the maximum allowable operating speed of the miles per hour equal to the square root of a actual elevation of the outside rail in inches divided by 7/10,000ths of an inch degree of curvature. Actual elevation of 15-foot track segment body of the curve is determined by average elevation of 10 points throughout the segment of 15.5-foot spacing. The curve of the length is less than 155 feet, averaging the point of full length of the body of the curve. Degree of the curve is determined by the averaging degree of the curve over the same track of the segment as the elevation. Guidance. Paragraph B1 prescribes the formula to be used to determine the maximum train speed of the curve based on the average curve alignment of the degrees, the amount of the super elevation in the same location, some of the combination of curvature or elevation resulting in the speed limitations may exist. It should be considered throughout the curve when determining compliance with this section. A railroad car traveling around a curve subject to the outward horizontal central force acts conceptually. The car's gravity wave at the center of the curve tends to overturn and directing the weight toward the outside of the rail. To counter the centrifugal force, the outer rail is evaluated with over the lower rail super elevated. In fact, the combined effect of the centrifugal force weight puts the restraint forces into intentionally move toward the center of the track. A balanced equilibrium condition implies the vertical forces on each of the rail are equal. Figure 8 illustrates three types of balance conditions: 10 miles per hour, overbalance, equilibrium, and underbalance, 4 degrees, 5-inch super elevation curve. In practice, railroads generally do not operate the trains at balanced speed. That is, the train speed is set for the resultant force stored with the outer rail, resulting in the unbalanced typical less than 3 inches. Unbalanced or cant deficiencies in theoretical amount of the elevation that would have been added to the existing evaluation to achieve the balance condition. The track safety standards class 1 through 5 limits the amount of the unbalanced 3 inches except for the 4-inch permitted with the authorized approved. The equipment types waivers have been granted with the operation at even higher levels and cant deficiencies. Serving curve and the speed that depended on the engineering characteristics of the specific equipment involved, as well as the track conditions, equipment, the factors such as the center of the gravity and the height, the suspension characteristics, reaction of the wind, or other factors, and consideration. FRA makes the decision to approve of the particular level in the cant deficiency specified equipment. The application of the Vmax formula using average technique over the 155-foot window. As indicated with the subnote 1, the maximum train is based on the values obtained with the curve of the body only. The actual evaluation of the curve is to be used in the formula determined by the average elevation curvature of 10 points, including to the point of the concern of the total of 11. Through the segment of 115.5 feet, the spacing 31 and 62 foot chords, the curve is the length less than 155 feet, and the measurement is average over the length of the curve. In order to determine the average curve, the inspector must calculate the degree of the curvature on the chord length, length used in 31 foot or 60 foot chord with the mid-chord offset measured at each station. For 31 foot chord, the degree of the curvature is determined multiple mid-chord offset with the factor of 4, 1/4 inch for each 1 degree. For the 62 foot chord, 1-to-1 relationship of 1 inch is equal to 1 degree. An additional limitation of reversing of the elevation contained with the table 21363, the Vmax formula, the maximum authorized speed of the curve reserve elevation occurs when the inside of the rail is higher than the outside of the rail, usually unintended consequence of the trajectory graduation. The condition can also occur where the turnout has been installed with the main track. The equilateral turnout considered as constructed with the left-hand curve. The calculation of the maximum authorized speed of the curve with the negative elevation is performed in the same manner as the positive elevation. For example, the maximum authorized speed approximately 13 miles an hour. Curve segment and agreed average curvature 4 degrees and 2.5 inches of the reverse elevation, both calculated over a 150-foot window with the length of the curve. The calculation of 3 inches unbalanced would be also shown below. The Vmax is equal to the EA of the 57B of the Table 1, Appendix A of the maximum allowable operating speeds computed in accordance with the formula version of the degree of the curve. Once again, Vmax is actually maximum allowable operating speed, actual elevation outside of the rail, and degree of the curvature. 57C1, the rolling meeting of the requirements specified in paragraph D of the section, the maximum operating speeds for each of the curves determined with the following. Maximum allowable outer operating speed is equal to actual elevation outside the curves, outside the rail at 4 divided by degree of curvature. Paragraph C permits to improve the type of equipment that has been qualified approved by the FRA in accordance with the paragraph D to operate the maximum allowable operating speed based on 4 inches of unbalanced cant deficiency. The inspector must be aware of that those vehicles have been approved by the Associated Administrative Safety Operation of 4-inch unbalances. 57C2 table, the Appendix A of the table, the maximum allowable operating speed commuted with accordance with the formula variations and the degree of the curvature of the guidance to C. Appendix A, the qualified equipment that may be operated with the curving speed is determined by the formula. Paragraph C of the section provided each of these last for the specific approved with the Operation of Federal Railroad Administration. The railroad demonstrates when that 1, the position of the track with uniform 4-inch super elevation rolling angle between the floor of the equipment and the horizontal does not exceed 5.7 degrees. 2. When the position of the track of the uniform 6-inch over elevation, no wheel, the equipment unloaded with the value of 60% of the static value of the perfect level track. The rolling angle between the floor of the equipment and horizontal does not exceed 8.6 degrees. 3. The track owner shall notify the Federal Road Administration not less than 30 calendar days prior to the proper implementation of the high curve speeding allowed under the formula of paragraph C of the section. The notification shall be written and shall contain a minimum of the following information. 1. A complete description of the class equipment involved with the schematic diagrams of the suspension system, location of the center of the gravity above the top of the rail. 2. A complete description of the test procedure instrument used to qualify the equipment to maximum values of when wheel unloading and the rolling angles were observed during testing. 3. The procedures and standards and effective of the maintenance of the suspension system and a particular class of equipment. 4. The identification of the line segment of the high curving the speeds of the proposed and the implemented guidance. The engineering testing prescribed in the paragraph D is now known as static lean testing, which has been used by the FRA for several years to evaluate the vertical curving performance. For modern rails, the high center of the gravity is 90 to 98 inches of the low speed curve with negotiation excessive levels of super elevation places the vehicle in an increased state of over imbalance. The condition creates a possibility of the wheel unloading and subsequent wheel climb with the warp conditions are encountered within the curve and explained within footnote 1 of the service table of statute 21363. Guidance, back to the italics. I didn't read the footnote. 57E, the track owner operator passenger commuter service will provide to the passenger commuter service over the trackage. More than one track owner with the same class of equipment may provide with written notification of the Federal Railroad Administrator with written consent of their own other affected track owners. Guidance. Paragraph E provides that the track owner, the operator, the passenger, the commuter services of the trackage of more than one track owner with the same class of equipment to provide with the notification of the FRA with the consent of the other track owner. Under the paragraph F, equipment presents operating higher levels of unbalance of the reason for conditional waivers graved and granted, but the FRA considered to have complied with the provisions of paragraph D. 57F, equipment presently operating with the curving speed allowed with the form of the paragraph C of the section reason for the conditional waivers granted with the Federal Railroad Administration shall be considered to have successfully completed with the requirements of the paragraph D of this section. Guidance, where the FRA has approved higher levels of unbalance include it is because the imperative that the inspector monitor the maximum authorized speed based on the approved unbalance. The calculation of maximum authorized speed for the particular segment of the track involved the substitution approved unbalance of the Vmax form that the calculation is based on the 10 inches in station plus the point of the concern the total of 11 stations of the space of 15.5 foot part or 62 by 31 foot chord. For example, the FRA approved at 5 inches for the cant deficiency, the particular of the type of equipment, the maximum curving speed of 60-degree curved segment of the 4.5 inches of the elevation would be calculated as Vmax versus the degree and the determine the enforcement action that is necessary for the inspector to determine the actual unbalance based on the speed that the railroad is operating around with the curve of the actual track conditions. In order to calculate the unbalance, the inspector must solve the following formula in the same Vmax formula represented with a different form. For example, if the railroad operating with the curve of 100 miles an hour, the inspector determined the field measurement, the averaging curvature of the average elevation for the particular curve of the segment is 2 degrees of the 5.5 inches elevation, respectively, unbalanced by the calculated by EU scientific notation. Where the FRA has not approved of more than 3 inches of unbalance, the operating speed of the curve to produce the more than 3 inches of unbalance, the inspector will record the circumstance of the defect. However, the inspector should consider the writing a recommendation for civil penalty level unbalance if the based on the maximum speed, elevation, and curvature exceeding 4 inches. When vehicle types have been approved, the FRA curve of the speed producing the 3 inches unbalanced, inspectors will not consider recommending the violation with the operating speed. The equipment to only produce the marginal level of the cant deficiency of the above approved level. The regional track specialist should be consulted with the questions of area arising concerning limits, speed, curves, and for example, showing the relationship with the curvature, elevation, and speed. Alright, the figure 9 is a chart of elevation mid-chord offsets in degrees from points -5 to 5. That means they have an 11 set, or 10 in a common point through the original equations. This one 57. Track of the railroad operating with Class 5 speed may request an approval of the Federal Railroad Administrator to operate the specified equipment at a level of the can deficiency greater than 4 inches in accordance with the statute 213-3229 C and D of the curve of the Class 1 through 5 track where contingents of the high-speed track are provided. 1. The track owner of the railroad submits the test plan with the Federal Railroad Administration for the approval not less than 30 calendar days to any proposed implementation higher than curbing the speed. The test plan should include the analysis of the determination, car body, acceleration, safety limits for each of the rail car with indicated with the wheel loading of the 60% of the car, 60% in the steady condition, and 80% of the transit point-to-point condition. Accelerometer shall be laterally orientated with the floor mounted near the end of the representative rail of the car of each of the type. Upon the FRA approval of the test plan, the track owner of the railroad conducts an incremental increasing the train speed testing and runs of the curve identified by the track segment to demonstrate the wheel loading of the limits within the limits prescribed in paragraph G1 of this section. Upon the FRA of the cant deficiency, the track owner of the railroad inspects the curve, identifies the track geometry measurement system qualified in accordance with the statute 213-333. B through G, and the inspection frequency at least twice annually will not less than 120 days intervals with the inspection. The track owner of the railroad operator is instrumented with the car having the dynamic response, the characteristic representative other than the equipment assigned with the service of the portable device is monitoring onboard instruments of the training over the curve. They identify the track and segment the revenue speed and the profile of the frequency at least one over the every designated period, not less than 30 days interval. The inspection instrumented with the car with the portable device and shall monitor laterally orientated with the accelerometer player placed near the end of the rail of the floor. Level. If the car body lateral acceleration measurement exceeds the safety limits prescribed in paragraph G1, the railroad shall operate the train at the curve at any speed in accordance with the paragraph BC of this section. The track owner of the railroad shall maintain the copy of the most emission of the prints of the inspection required on the paragraph G3 and 4 of this section. Paragraph G permits the high-speed railing operating with Class 6 through 9 with the contingency with the next two the curves of Class 1 through 5 to operate with a higher level unbalanced curve provided with additional inspection requirements that are maintained. Inspectors should commute the allowable speed for the curves determined with the compliance with the section reported defects which the train speed exceeds allowable based on the formula. In many cases, the high-speed railroad will accomplish testing requirements of Class 1 through 5 during the qualification tests of 213-345 and 213-329 over the entire route, which include both low and high-speed curves, and in those cases, the FRA approval is generally applied with all curves en route. However, the FRA may approve the different speeds, the deficiencies, different track segments, and depending upon the result of the testing. 213.59 Evaluation of curve track runoff. 259A The curvature evaluated. The full elevation must be provided with throughout the curve unless the physical conditions do not permit the elevation of the curves. Occurs in the curve, the actual minimum elevation must be computing the maximum allowable operating speed for the curve under statute 213.57b. Section 213.59 is closely connected with 213.57 and 213.63 when determining the curve of the track in compliance with the track safety standards. Inspectors should consider 213.57, 213.59, 213.63 in conjunction with one another because the language of 213.59 explanatory nature intertwined with the requirements of statute 213.57, 213.63, and 213.59. Should not be able to stand alone in support of alleged violation. The FRA should cite either the 213.57 or the 213.63, whichever is more applicable. According to the FRA, has not included the defects of statute 213.59. 59B, the evaluation must be uniform rate with the limit of the track safety surface of deviation from the statute 213.63. It must be of extent less than the full length of the spiral, and physical conditions do not permit the spiral long enough to accommodate the minimum length of the runoff. Part of the runoff may be tangent track. Items considered with respect to the runoff included the following: the elevation beginning with the body of the curve rather than the point of the curve as a spiral, least average elevation existing for the body of the curve when governed when the allowable operating maximum speed throughout the full of the curve. Evaluation of the end of the curve maximum between segments of compound curves must be at a uniform rate of the limits of the track safety deviations as described in the table under 213.63. Particular attention must be given to the prescribed limits differences with the cross level between the 2 points of the 62 feet apart in spirals. If physical conditions do not permit the spiral long enough to accommodate the minimum length of the runoff can be carried out in the tangent. The circumstances of the surface of the table, the parameters as done in the statute 213.63 govern The actual minimum elevation actual degree of curvature determined by using the average techniques described in Statute 21357. Figure 10 illustrates how the railroad car reduced the super elevation body curve to accommodate the highway railway grade crossing for unqualified equipment 3 inches unbalanced. To 1363 track surface. Each owner of the track which in the part supply shall maintain the surface of the track within the limits prescribed in the following table. Runoff within 31 feet of the rail at the end of the race, not more than one of the class 1 and through 5. I'm just going to read the track surface conditions, not the inches or anything. I don't think we all have the brain to keep the tables in our head. The deviation uniform profile, either the ordinance 62-foot chord may not be more than deviation 0 cross the level at any of the point tangent reverse with cross level evaluation curves may not be more than. Difference of cross level between any 2 points less than 62 feet apart may not be more than 1 and 2. Where determined of the engineering decision prior to the promulgation of the rule due to the physical restriction of the spiral length, operating practices experience variation cross level of spirals within 31 feet may not be more than. Guidance track surface is unevenness of the uniform track is in short distance measured along with the tread of the rails. The underload of the track structure gradually deteriorates due to the dynamic and mechanical wear and effects of passing train, improper drainage, unstable roadbed, inadequate tamping, deferred maintenance, and can create the surface irregularity. Track surges. Surface irregularities can lead to serious consequences ignored or allow deviation of the track surfaces, including runoff at the end of the division of the deviation of the uniform profile, deviation 0 cross level at any point of the tangent reverse cross level. Elevation of curves and difference of the cross level between the 2 points at the less than 62 feet apart specified in the track surface table. In addition, the table includes the footnotes and address 3 special circumstances. The first paragraph of the table, the section referred to as ramp off and any 31-foot segment end of the race with the track evaluated with the result of the automatic manual fixing bridge work condition created with the track degradation, settlement, and the frost and the heave, and addressed upon the uniform profile all parameter under the section. The trains encountering the ramp up and down will experience a vertical pitch bouncing of the chain. Evaluation occurs, but the toe is short of the distance as within minimal. More general profile parameter damage to the components undesirable braking application derailments may occur, especially when the vehicle experiences lateral surface from such buff force. Figure 11 illustrates the measurement of runoff of the raised track. Shows the 31 foot and the string of the runoff. That's your difference in the elevation or super elevation. Second parameter relates to the evaluation of either the rail along the track, whether the track encounters a short dip or hump of the track, that can be resulted in vertical separation. Coupler, broken springs, bolster, truck frames. Dips can be result with the mud spots developed in forest ends of fixed structures, bridgeways, highway, railway crossing, track crossings. Profiles is determined by placing a midpoint 62-foot degree 50-foot chord at the point of the maximum measurement in respect of the vertical curves. Profiles may also be a track hump causing a frost heap or other occurrence. Figure 11 illustrates measurement of profile and conditions. A 4-inch block, any size appropriate situation, 1-inch measurement, 62-inch string. Dip elevation 62 inches. Remember to consider combination of rail and tie plate cross tie baseless section avoids the mid-orientated with accordance with the 213.3 dynamic loading. When encountering a hump, the frost of the heave of the culverts placed to uniform reference the offset blocks at the top of the running of the rail, stretch the taut 62-foot string positioned over the block to observe the high point of the midpoint of the string. Measure the distance of the string of the running of the surface of the rail. Subtract the distance of the height of the offset blocks to determine the mid-offset. Third parameter is the table that refers to the deviation of the 0 cross level at the point of the reverse cross level of the curve. The cross level over utilizing the level of the board is measured with subtracting the difference between the height and the top of the surface tread on one rail and tread to the opposite rail. On a tangent track, both of the rails should be at the same height at the time, term known as 0 cross level. On the spiral body of the curve, the other outer rail may not be lower than the inner rail. Reverse elevation beyond limits is provided with the surface table and all consideration implementations of the Vmax 231.57. Maximum allowable speed may impose the curve of the body with the reverse elevation encountered. The parameter is the difference with the cross level between the 2 points less than 62 foot apart. commonly referred to as warp parameter. The parameter provides the maximum change of the cross level between the 2 points within specific distances along the track of the warp. The parameter is measured. Perhaps most critical, the surface of the parameter's excessive warp contributes to wheel climb derailments. Figure 13 shows the warp measurements. Tangent and curved body spiral. Threshold valve of the warp represents the minimum safety standards encompassing the full range of the rolling stock of the present operating fleets. Inspectors should be aware of some of the rolling stock because of the certain design to demonstrate that the performance characteristics may be subject to additional operating restrictions and or restrictive warp thresholds as determined with the individual railroad. The limits of the warp and anywhere along the track, curves, spirals, tangent segments, except as the limits shown in the footnote of Statute 21363, Table 6, applying special cases of spiral with physical condition preventing more of the restrictive limits of the general parameter. The footnote designates a Statute 21363 table as an exemption above the warp requirement. Special rules in few situation where the railroad has prior to their engineering decision due to the physical restriction designed to a short spiral that would be found in the standard construction. When encountering a spiral that does not have a sufficient length of runoff elevation in accordance with the warp parameter, the inspector must determine the short spiral the result of man-made or natural obstruction. Ensure or the spiral the amount of the warp determined by measuring the variation of the cross level between the 2 points of 31 feet apart. Simple short spiral situation included by rock cuts, tunnels, and station platforms, etc. Figure 14 of application of the footnote. Railroads are expected to imply the variation parameter thresholds of only the location of the clear history of restricted physical characteristics. When measuring the track surface parameters, remember the location of the transition points between the tangent, spiral, and curved body to determine the actual physical layout. There may not assume to be synopsis for the railroad markers with tags and curve charts, signal information. Therefore, the governing according with the applying in the footnote any other track geometry parameter. Under footnote number 1, the Statute 21363 Table 6, the evaluation at any point of the curve that equals exceeding 6 inches. The difference of warp at the cross level of 62 feet between the point and the points of the greater elevation may not be more than 1.5 inches regardless of the track of the class. Footnote is included with the dressing condition of the vehicle and the operation of the curve. The large amount of the evaluation of the encounters of the warp condition. If the vehicle is typically unbalanced condition, the warp induces the wheel climb, slowly speed the negotiation particular concern, and since the wheels are on outside the rail of the curve, will tend to undo the overbalance condition of the vehicle. Where this condition is found, the appropriate corrective action would be reduction in class 1 speed under the provision of Statute 213b. Figure 15 illustrates a warp exceeding 1.5 inch of the curve with 6 inches of elevation. Alright, footnote number 2, the table 21363, table 6, addresses the critical harmonic rock-off condition that becomes the vehicle rocking back and forth, derailing, following wheel climb. It is considered the rare of the condition can occur with a continuous welded rail, but it may occur with the joint memory existing. In the case of the condition is not defective unless it exceeds the warp limits specified in the table. The inspector shall and be conditioned to the attention of the railroad. The cross-level differences warp may not be experienced exceed 1 1/4 inch on all 6 consecutive parts of the report joints under the convention of joint spacing 36, feet long rails. Each one of the 6 spacers must not exceed 1 1/4 inch of the condition to be defective. Additional joints have been introduced outside the regular joint space characteristically as a result of repair are not considered harmonic joints for the purpose of the footnote. Figure 16 illustrates harmonic rock and the conditions. A condition's consecutive low bottle joints may not be in compliance with either the warp elements specified in the table of the requirements of footnote number 2, the Statute 21363, Table 6. Inspectors should consider a continuous group with locations 1 defective note of the number of joints. If the harmonic condition continues beyond the 7 joints, the inspector is not required to. Another defect must be the number of the consecutive joints that make up the harmonic condition. Alright, joint rail staggered, non-identical stagger to stagger, such as the curved one in a rail slightly larger than original construction installed shall be constructed. Harmonic calculation. Individual joints introduced. Installation of short rails are ignored in the evaluation of harmonic condition. Construction consisting of 79 to 80 foot of the repaired rails do not result in harmonic walk-off conditions since they occur outside the vehicle. Truck spacing 79 to 80 foot rails staggered space less than 10 feet. The footnote is applicable. The inspector shall review the condition compliance with all other track surfaces and parameters. Inspectors should carefully apply the provision of footnote number 2, see Statute 21363, Table 6, an acceptable remedial action to raise up the tamp one or two joints in the middle of one of the consecutive load jumps. This will break up the harmonics. Subpart D, track structure.